There's an A and a B for calc, and an A and a B for. Is that what you did?
That's like one size race for 60 years.
There, it's one. One is one, except they're different numbers. They're the same, except they're different. Different, same type of question. The conduit might be, as a matter of fact, one of them, the conduit PVC schedule 40, and the other one is conduit PVC schedule 80. Same information. I just changed the conduit for you. Is that sneaky or what? Okay, very sneaky. Question number one. Oops. Here's a question number one. So I need to size the conduits. You guys have the information in front of you. For 3 conductors 4-aught, 1 conductor number 3 and 1 conductor number 4. All of them are THHN, right? So let's go ahead and do that. I have 3 conductors number 4-aught, and I have 1 conductor number 3, and I have 1 conductor number 4. This is for 8. We're doing version 8. And and all of these conductors are, all conductors, all are T, H, H, and N. All of them are T, H, H, and N. Easy, typical. Okay, so here's what you're going to do. First, you're going to find the cross-section area for these conductors. Where do you find this one from? Table 4 or 5? Table, is it 5? Table 5, chapter 9. So you're going to go to table number 5, chapter number 9, and find the information. Okay, please correct me if I do something wrong. 3 times 0.3237, and then 1 times 0.0973, and another 1 times the cross-section area 0.0824. If you do the math on all of these and add them up, you're going to end up with 1.1508 square inch. And if you take the 1.1508 square inch, take this baby to table number 4, chapter number 9, right? Chapter 4 this time.
Yeah. Square inch or cubic inch?
Oh, did I write cubic inch? Square inch, I'm sorry. Square inch. This is square inch. Cross-section area, square inch. And then that will give you, if you guys go there, it will give you 2.1, 2.5. You get a 2.5. And what conduit? Yeah, the conduit is, I need you to do PVC schedule 80. So this will be 2.5 PVC schedule 80. Done. Anybody came up with something different? Shall we attempt to do this one on the calculator? Attempt doing it on the calculator? Okay, so let's do our conduits. What was the conduit for EMT? Because Nick told me to do that one. Conduit EMT is which number? EMT is 2. No, 1. EMT is number 1. So click your calculator. Have your calculator handy. I don't need EMT though. I need PVC, right? So PVC schedule 80 is 9. So click on 9 conduit. That will switch your conduit into, oops, what did I do here? 9 set conduit. Okay. Why it's not switching it? Is it 9? 9 PVC schedule. Okay. Oh, I see what you mean. So 9 set conduit type. Here you go. 9 set conduit type. Everybody's 80. Let's go ahead and do it. 4-aught. Let's do a 4-aught. 1, 2, 3, 4. Wire size. What's the insulation type? THH. Oh, you need the number first. 3 conductors. THHN, hit again, give you the fail. The second one, guys, is 3 conductors, is number 3. Wire size, number 1 conductor of them, THHN, hit again, here's the fail. And the last one is 4, number 4. How many of number 4 do I have? I have only 1. What type? Insulation, THHN, hit again. and hit the conduit size, and you get you 2.5. Anybody came up with something different than 2.5? 2.5. Any question, guys? Any question about that one? Okay, as long as we're on it, I'm going to do question number 1 in B, guys. And I'm going to do in the calculator the same information, except the same thing. Question number B, guys, is the same thing, same information, except the conduit is schedule 40. So I'm going to go switch my conduit to schedule 40. So I'm going to go 10, schedule 40 from that the thing is 10. So I'm going to hit 10, sorry, 10. Where's my 10? 10. Set conduit, and I get, did you guys get 2 inches for that one? 2.5 we got. We got 2.5. Or no, schedule 80. Schedule, no, 2 inches. 2 inches. Yeah, 2 inches. So switch the conduit into schedule 80 and you got 2 inches. So if you have question number for B, this is for A. If you have question number 1B, your answer should be 2 inches PVC schedule 40. Cool? Two inches. Anybody came up with something different, Chris?
Yeah, I came up with 2.5, but I'm just looking at what I must have. Oh, 3. Yeah, there we go.
Okay, found your
number 4 is rather than.
Okay, you click a different numbers.
Yeah, I was looking at.
Okay. Any question, guys, about how to use a calculator tool? This is a nice tool. All right. So let's go down to next. Okay. All right. So question number 2, my friends. Any question about one? Question number 2 is rigid nibble conduit, 24 inches. That's, you might not be able to use a calculator with that one. So question number 2. Question number 2. I have a nipple rigid metal conduit. This is for A. For A, it's the rigid nipple conduit, and it's the inch on it is 1 inch. So how many conductors can I add to it? How many conductors can I add to it if it has 4 number 10? It has 4 number 10, and it also has 1 number 10. This is T, H, H, N. This is bare. And the second one is, okay, so that's it. And I need to find how many conductors number 10, extra number 10, I can add. How many extra number 10 can I add to this conduit, inside this conduit, pull inside this conduit? Okay, if you guys go translate this one directly into 4 times 0.0211, and the second one is 1 times 0.011. The challenge is to go to table number 8 here, chapter number 9 for the bare conductor. That's really the difference. Everything else is from chapter 4 and 5. If you do it this way, you came up with 0.09954. That's the occupied space. The second thing you need to do is find the available space for 1 inch rigid metal conduit at 60-degree fill, because it's a nibble. You're going to find it's going to give you a 0.532, right? Step number 3 is to take the available space, or the space in the conduit, subtract from it how much already occupied inside that conduit, and you're going to get a healthy 0.432 366, and the last step is to take a 0.4366 and divide it by how many conductors, the cross-section area of number 10, right? Number 10, which is 0.0211, and I don't know about you guys, but I came up with a 20 conductors number 10. 20 conductors number 10. Any question, guys, about that? Anybody came up with something different than 20 conductors number 10? Oh, by the way, this is for B. Sorry, this is B. This is for version B.
Where did you look up the cross-sectional area for our pair?
The bare conductor should be chapter 9 under stranded. Table 8, chapter 9. Table 8, chapter 9. Stranded. Point 532. This is from chapter 9, table number 4. 1 inch rigid, right? This is for B, guys. For your A version, if you have an A version, your answer should be 11. The same calculation for A. Can I put the A here? Same calculation for A. The answer should be 11, number, what is it? Number 10. Can I trust that you guys will do that? For A, it should be 11, number 10. Any question, comments about this? Nick, do you want me to go over it?
Just, and then once we got it 1 inch on the C, right?
Yep.
Then we have to go under the 60-degree column?
Yep. Because it's a nipple. Nipple is 24 inches or less. Yeah. Remember we said, guys, 24 inches or less special treatment, we treat them? Any question, guys, about this? Everybody got the answer for A and B? Version A, version B. Now we're alternating, so let's go to version A again and do number 3. Move, no, stop, slow, feedback. Ashley, my friend, good? Okay, let's go to question number 3. Question number 3, my friend, is a J box or a Boxful calculation. Boxful calculation. It says, here's the description of the Boxful calculation. The Boxful calculation, and I have 4 by 1.5 inches square box, and I also have Mr. Ring. The square box, cubic inches, as you guys know, the cubic inch for the square box, 4 by 1.5 inches is 21 cubic inch. The ring is given at 3.6, so you add them up, and you're going to end up with a 24.6 cubic inch. That's the box. The first thing you need to do is find the available space in my box, right? Just the box. The second, this box is housing the following. It has 2 duplicate receptacle, 5 number 14 conductor, and 2 equipment grounding conductor. Okay, let's find the occupied space. So I have conductor. How many conductors do I have? Let's do them right here. I have number 14. Number 14. For number 14 conductors, guys, I have 5 of them. Each one of them will get 2 allowances, 2 cubic inches for each one. I have a ground. All the ground are going to count as 1 based on 1. Based on 2, the largest. And the devices, my devices, I have 2 of them. Each one of them is going to count as 2 based on the largest in the box landing on it, which is 2. So if you add this, that will get you 20 cubic inch. 20 cubic inches. The last thing you need to do, any question, guys? Find the occupied space, the available space. Subtract the 2 spaces from each other. which is 24.6 minus 20, and that will get you 4.6 cubic inch. And the last step is to take your 4.6 cubic inch divided by how many conductors I need to pull through. Conductors, box contain 2 duplex. Okay, how many? Extra number 14. Extra number 14. Okay, extra number 14 is 2. So if you guys do the math on that baby, you end up with 2.3. And guess what? There is no 2.3 conductor. So that will be 2 conductors number 14 are as max as I can pull out of these conductor. Everybody's following me why I divide by 2? Because his cubic inches is 2 for number 14. Tau, had I asked you about number 10, it will be 2.5. Divide by 2.5. If this is for 3A, if you did 3B identical, except I'm asking you guys, what did they change? They changed a few other things. Did they change even? Yeah, we end up with 4. 3 conductors, double receptacle, 3, okay. Okay, number 14 conductor pull through. Yeah, what was, I changed a few things. Yeah, instead of 5 conductors, I put 3 conductors number 14. The same thing, if you're doing number, this is for A. If you did a B, your answer should be, if you did a B, your answer should be for number 14. Your answer should be the same calculation, guys, same calculation. You know what I did, Ashley? I made, instead of 5 conductors, I put 3 conductors. To make it, the idea, Nick, is to make it equally challenging for all of you guys, so I don't give a brand new, I just changed a couple of numbers here. You know, multiplying by 3 or 5 is really didn't change the challenge of the question. Okay. Yes, sir.
I don't know how you do the devices.
The device, I have 2 of them, right?
Is it a 2 duplex receptacle that makes it 2?
A 2 duplex receptacle count as 2 receptacles. A duplex is 2 receptacles in 1 yoke. A 2 duplex is actually 2 devices. Did you multiply before?
Do I use it for 1?
Quad, you treated it as a quad. Even as a quad, it's going to count as 4, though. As 2. Because they're 2 big yokes, I guess. Okay, any questions about this? We can't use it in the calculator, so. All right, let's go to 4. My 4 is J-box. Question number 4. We're going to do it in the B now. B. Question number 4, version B. B. I have a J-box. Beautiful J-box. Just beautiful. You guys have an issue with the beautiful J-box? My beautiful J-box is pulling conductors through it. And I need you guys to find the distance x1, the distance x2, and the dimension y and x. Y and x. Looks like an x. X. Okay? This is my pull box. 2 angle pulls, and I need you guys to find the x and the y for this box. Piece of cake. The first thing, let's do x. X dimension. For x dimension, my friend, the only way we can get x is from an angle pull, right? Angle pull, how many angles pull do I have? 2. You take the largest conduits engaged in an angle pull, multiplied by 6, plus all the conduits, looking at it from here on the same wall. So 6 times, what are the conduits? We didn't put the conduits. All the conduits are, what's the conduits? 3. All my conduits are 3 inches. 3 inches, 3 inches, 3 inches. So 3 times, 6 times 3 plus 3, 18, 21. 21 inches. Done. For y, any calculation for y guys, dimension, any calculation for x dimension. That's the only calculation you can find for x dimension. For y dimension, the same thing, looking at it from the Y point of view, from the top to the bottom, that will get you the same calculation, 6 times 3 plus 3 equal 21 inches. So XY, the dimension of the box is 21 by 21.
So the U-pull from left to left.
U-pull. Did they show you a U-pull? Did they say U-pull in the box? I described it as the distance from the left wall to the right wall, the distance from the bottom wall to the top wall. Okay, on the side, race width on the top.
Yeah, you didn't describe
The
pull
depth.
at all, it just described the box.
The distance between any two race widths containing the same conductors. Okay, even if you do the U-pull, what do you get? Get the same answer, right?
Yeah.
U-pull.
Yeah,
No,
you have to.
absolutely. I have to describe it. If you have a U-pull,
No, I got-
yeah, I should have described that they're going pulled through distance from the left to the wall. Okay, yeah, you're right. You can do a U-pull, but it wouldn't change the. If you do a U-pull from here, it will be 6 times this plus this. Same answer. But
What I'm thinking of when you use it for X and Y, you don't have any other you pull again. The conduit is already filled. Now what are you pull? You don't have you pull again since you have X and
You don't
Y
know what
already.
it's for.
we're sizing the box where the conduits are going to be terminated to. That's what we're doing.
Oh, that's
Yeah. But why are you talking about pull conduit?
when you have X dimension and a Y dimension.
Yeah.
What other sizes do you have there? No other sizes again of you pull.
I'm not following all of you. You might have to come over here. Come over here, buddy. Move it. That's the donuts that I gave you. Is effective. Yeah. Well, what we're trying. Good.
What I'm saying is that when you made a calculation for X dimension,
Yes.
that is from left to top.
Yes.
Then on Y dimension, from
Top to left. Yeah. What happened to top to right?
Top to right, we don't have anything.
Absolutely.
Yeah, and now you have engaged all those conduit sizes now. Where are you want? Where do you want to find the U-pull? You don't have any other U-pull again.
I see. You're discussing is where would you going to have a U-pull?
Yeah.
But what Chris is saying is, if I don't draw the box like this for you, if I just give you the box and I don't draw these, see these dotted lines, the way I showed them, you could technically bring a U-pull from here to here and another U-pull from here to here. It wouldn't change the dimension size. It would be exactly the same. You could. But Oladipo, my friend, another thing. Can I pull another conductor? Suppose, can I pull another conductor from here and go back here in the same conduit? Sure, not a good idea. But can I pull two conductors in a conduit? One of them go angle pull and the other one go U-pull? No problem. Not a good idea though. Talk about feeders here. Okay. If you guys, this is for B. If you did an A, oh no, we didn't finish this one yet. The depth. I'm asking you guys the depth by giving you a conductor that's going to be sitting inside, and that conductor, what was the conductor? The conductor is 500. So to find the D, the depth, you take the 500 like we did KCM to table V 12.6 A, and that will give you based on one terminal. Number 6, right? Everybody knows how to find the depth. And the last one is x1. x1 equal the distance between them equals 6 times 3 equal 18 inches, and x2 equal 6 times 3 equal 18 inches. The distance between the conduits. Oops. The distance between the conduits. 18 inches, the distance between the conduits. Right? Any question, guys, about this one? So that was for B, right, Chris? Was for B. Now, if you go to A, if you go Mrs. A, the same thing, guys, except the dimension will put them right here. Dimension end up being 14 inches here, and again 14 inches here, and the distance is 12 inches. 14 inches, 14 inches. Yep, this will be 12 inches. No, not that. So dimension XY, and the depth continues to be number 6, and the distance between them, this is a 12, and this is also a 12. Are you with me? The distance between the conduits containing the same conductors at 12, 12. The dimension of the box is 14 by 14, and the depth of the box is 6. For A, this is for A, Miss A version. Any question, guys? A version. Shall we go to 5? Shall we go to 5 now? All equal?
Yeah, I don't know how you, why do you pick 6 then? Because you said the distance is 2 inches and 3 inches. I think you should go under 3 inches and 2 inches.
The 6 we go by the size of the cable coming from the back. We size it based on the cable. The cables coming from the back is 500 kcm for both of them. You take the 500 kcm to table 310, 312.6a
Yeah.
under one terminal. What do you get?
Use
One terminal. Yeah, one terminal. Good point, Mr. Oladipo. Okay, can I move to the second one? Number 4, number 5? Number 5. Let's go question number 5. Number 5 for A. Question number 5 for A, guys. I have 8 conductors hot. Number 12, installed at an ambient temperature of 100 Fahrenheit. Find how many amps you can pull out of this baby. That was easy, piece of cake. How many conductors do I have? I have 8, number 10, T, H, H, N. All of them are hot. So, and the ambient amp temperature, or we don't want to say amp because it's, and the second thing, ambient temperature, or temp. The temp that I have is 100 degree Fahrenheit. So what's my question, Chad? Find how much current this conductor can carry under these circumstances. So you take number 10, take it to 310.15B16 under 90 degree column. And if you guys went there, you'll find it's 40 amps. Then you take the second step, you take your 40 amps and slam them, the rating for temperature, 0.91, the rating for conductor bundling, 0.7, and up it goes with 25.5 amps, give or take. If you are a virgin B, this is virgin A. If you are a B boy or girl, your answer should be 47.8 amps, give or take. This is for B. Any question, guys, about this? Straightforward, same calculation. Okay. Any question, my friends? Okay, I'm going to move to the next one. Can I? Yes. This one? Yeah, no. I doubt that we would. Let me just see. Set 90. Let me clear. And let's go set my temperature at 90. And my conductors are 10. I don't know if I can 10 wire. The ambient temperature. What was the ambient temperature? Set ambient temperature. Let's go set the ambient temperature. The ambient temperature is
is 100. So 100 set ambient temperature. So I set my ambient temperature to Celsius. Oh no, we don't want Celsius, buddy. We're in Fahrenheit. Is that Fahrenheit? I'm giving you this Fahrenheit. Let me set again and see if it switch it to set temperature. Celsius. Where's my Celsius switching to Celsius versus Fahrenheit? That's a good point. What's the equivalent of 100 Fahrenheit in Celsius? That's a good point. If you from the book, that's I can't see how to switch it to Fahrenheit. 212. Okay. 100
Celsius is 212 Fahrenheit.
No, it's 100. I'm giving you 100 Fahrenheit, right? In the example. Okay, 100 degree. Oh no, the 100 degree Fahrenheit is Fahrenheit going back to Celsius is guys like 36 or something. I don't know. I don't know how to switch it to Fahrenheit, bud. You might convert. Yeah, using the calculator. I'm saying. I'm sure there's a way here. Okay, let's just say 60, 36. I'm just going to say 36. Set ambient temperature. It's still doing it in Celsius. Yeah, 36 Celsius is okay, close to 100. And then what did we say? Then my amps. I don't have amps. No, it doesn't do it. Sorry. You have to start with the conductor to get the amps, not the other way around. You have to start with the amp to get the conductor, which makes sense, guys, because you always size conductor. You don't find amps for conductors in the calculator. Okay, so we're going to switch on that one. We got B. Let's go to 6. Number 6. Number 6, guys, I have a panel, and I'm giving you the load. I'm giving number 6. Question number 6. I'm giving you the load and the overcome protection device. That confused some of you guys. My 800 amp panel and my load is 750 amp. And I want you to size the conductor. And I told you, good design to size based on 800, but I wanted you guys to use the advantage of up to 800 amp. The conductor can be slightly less amp than the overcome protection device. So technically, I wanted you to take divide these by 2, and you end up with 375 amp. Take the 375 amp, 310.15 B16 under 75 degree column. That would get you 2 sets of 500 kcm. 2 sets of 500 kcm. That's what the code allows you to do. Good design is probably to go to 2 sets of 600 kcm. If you use the calculator, guys, look at that one. Let's go change. I'm going to go change my ambient temperature is screwed up here. I'm going to go put my ambient temperature 30 so I don't screw up. Or let's go clear all. Clear all. Let's set it back for me. Clear all. Set it up back. Okay, I'm going to go set my conductors for 75. My conductor 75 cover 3-phase, perfect. So what's the size? I'm going to size based on 300, based on the amps. What's my amps? My amp is 750. 750. Can you guys see that? Here's my amps, and I need 2 conductors. I have 2 conductors, parallel wire size. Would it actually parallel right away? It brought it right. Let's do it. I just screwed it up here. Say thick 750 and amps, and just hit parallel size. You need to put how many? 2 of them, parallel size, 500. Now, some of you guys went to directed to the 800. If you take the 800, which from an engineering point of view is actually better, take the 800, put the 800 here, and hit 2 conductors because I'm asking you, and size parallel. You get 600 CU. Some of you feel you did both of them, that's fine. But take advantage, like you did in your company, take advantage of the code and make smaller conductor if you can. as long as you're paying for it, not me. Okay, so number five in A, number 6 in A, number 6 in B, the same question. I just made it 740. So for B, my friend, you should end up with for B, 2 sets of 500 kcm. This is for Miss B. Any question, guys, about A and B before we go to 7? Cool? Do I need more sugar on you? Nick, my friend, are you okay? Are you mad at me?
Yeah. Oh,
No? Okay.
Not like last time.
Not like last time. Question number 7. Question number 7. I'm doing a B. Question number 7 is B. I need to find the full load current of the following. Find the full load current, I, full load of a motor that's running at 15 horsepower motor, times it by 746. And the voltage is 3-phase, 1.73 times 480. I'm writing the formula right away, guys. Times Miss efficiency is 0.85, and Mr. Power factor is 0.9. And if you guys did this, you should end up with an 18 amps give or take. 18 amps give or take, right? So find the full load current of a motor, 3-phase, 480, 15 horsepower, power factor 90, and efficiency is what? Efficiency is 85. This is for B. If you did an A, you're an A individual, your answer should be for an A. For A, your answer should be, my friends, for number 7, should be 18 amps. Same way? Oh, okay. Oh, did I mess them up? No. 11. No, that's wrong. No, it should be 12. Sorry. Chad, I wasn't drunk last night. 12 amps. Okay, let's do this. We can do this in the calculator, all people. That's easy. Let's do this in the calculator, guys. Okay, here you go. Let's take how many horsepower? We're going to do it, guys, together. How many horsepower? Am I set to 3-phase? Yes. Look at the 3-phase. Set up 3-phase. Let's put the horsepower. 15. Here's my 15 horsepower theoretical value. And then I need my voltage. My voltage is 480. And you hit the voltage here. Perfect. And I need, what else do I need? I need the power factor. What's my power factor? 0.9. Where's my power factor? Set what? They'll get you the power factor. And what was the efficiency? 85? 85%. And efficiency is, you have to hit set and HP. So I put my efficiency, power factor, voltage, and horsepower. What do you need to think you hit now? Amp. What happened? Did I? Yeah.
Okay, that's why. So let's go, instead of 90% power factor, thank you. One of us is awake anyway. Set power factor 90. So don't put it as a percentage, because it comes as a percentage. And hit amps. Off it goes. Isn't that what we guys came up with? 17.6, close enough to 18. Okay, so if you're doing the other, if you're doing B, if you're doing A, let's do A right away on that one. Just because of the exercise. A, my friends, is 10 horsepower. I'm going to go 10 horsepower. The voltage still the same, 480, so leave it. The power factor is 85, and everything stays the same except the power factor. So go ahead, amps, 11. So can you see if things stays the same, you don't have to change it. It stays in the memory. So we have 12. Cool. Any question, guys? Shall I move to 8? 8. 1, 2, 3, 8. Let's go to 8. Question number 8. I'm going to do a B, because I'm at the B section. I have a transformer, guys. My transformer, I like to do the transformer. It has a 480
and on the primary has 240, and that baby is cooking 500 kVA, and I need to find a few things. Number one, the ratio. The ratio, as you guys know, you take the 480 divided by 120, that will get you a 2 to 1, not 1 to 2, 2 to 1 ratio. Number two, I need to find I primary. When you find I primary for a three-phase, what do you do, guys? You take the 500 kVA, 500K divided by the voltage. What's the voltage? 480. But don't forget, Philip, 1.73, the multiplier for three-phase. And that will get me 602 amps. And the last one, number 3, is I secondary equal the same kVA quantity divided by 1.73 times the voltage. This time is 240, so double the current. I have 1204 amps. So the amps on the secondary is double the amps in the primary. If you did an A, this is an A. If you did a B, my friends, I gave you a 1000. If you did a B, this actually was for A. If you did a B, this should be also 2 to 1. The amp here should be at 1204 amps, and the amp at the bottom should be 2408. This should be 2408 amps. These are B's. Let's do the calculator to find one of them at least. Take this. Let's take the 1000. Take the 500. Here's my 500, 0, 0. Here's a K. Where's my K? K, volt amp. What's the primary voltage? The primary voltage is 480. Here's my 480 and my volt. And what do I need to find? I need to find my amps. Here's my amps, 601.4. So that's where you get your 62. I changed my mind about the voltage. I'm going to go to the secondary, so I want to make my voltage 240. Here's all what you have to do is just pick up the voltage, and put a new voltage here. And guess what? The current is going to double, right? So 1204, close because of approximation and so forth. Cool? Yes, sir. Highlight it. No, I don't like it, but it's not wrong. we don't, when we talk about loads in amps, we don't use kiloamp. Kiloamp is a lingo that we use for short circuit. So at work, if somebody's asked you what size switch gear is this, and you can say 4K, in the mind of a lot of engineers, go 4K interrupting rating, that's short circuit. Usually for amp size of equipment, always in amps. 200 amp, 2000 amp, because they can go up to, all equipment guys can go up to 4000 amp, sometimes special 5000 amp and 6000 amp, that's it. But short circuit goes higher than that. Okay, any question guys? Chris, my friend?
Turns ratio on question A where you have 480 over 120.
Yeah, so 2 to 1, not 1 to 2.
120 goes into 480 4 times.
Oh, I'm sorry. This should be 240 here. This should be 240.
All right.
You're absolutely right. Thank you. This should be 240. It's right on the quiz, right? 240.
No, I didn't know if A and B were the same.
No, they're completely the same, identical. It's just your friend Chad said something and did another. Okay. May I move on to the second one, guys, so we can move? So this is number 7, number 8, number 9. Almost done. Number 9. Question number 9. We're doing B this time. We're doing a B. I have a store, a continuous load, and my load is 123 amp continuous, and I need to find the following. Number 1, overcurrent protection device. And if you guys remember, if it's continuous load for overcurrent protection device, you take 1.25 multiply it by 1, 2, 3. You're going to end up with a healthy 154 amps. You take the 154 amps, take it to 240.6, and the next standard up is 175 amp. Now, some of you guys went 150, that's okay. I'm asking you about the maximum that you can install for this feeder, the maximum. Maximum is you go up, 175. Okay, so you take the feeder, continuous load, remember. Now feeder, the feeder size, piece of cake, Chad, the same calculation, 1.25 times it by 123 equal 154. Take the 154 all the way to 310.15 B and 16 under 75-degree column, and guess what you get? You get your two beautiful 2-aught. How many conductors? 4 conductors of a 3-phase, 3 conductors of a single phase. Okay, doing the same thing on A. Doing the same thing on A. Yeah.
Why do you use the 75-degree column when you have pH return?
What else would you do? You go to the 90? 90 only for derating. Are we derating? No, now. Oladipo, don't jump into the last question that we did.
No.
We're in this question this time. I know. I know. But Ashley, we only go to 90 if we are derating. Are we derating here? For temperature, ambient temperature, or for, this is common mistake in the industry, because you don't size based on 90 unless you are derating. Even if your wires are rated, they don't make equipments rated for 90-degree lugs. You're limited to 75 lugs, no matter what, unless you go medium voltage. Okay? So that will be 2-aught. For A, guys, where's my A? For A, if you did an A, this should be 150 amp. Nick, is this where you cheated and you put 150 on yours? Number 1. And this is for A.
Oh, where did we get, for A, we calculated, we took 103 amps times 1.
Yep. 100 equal 129.
Yep.
Your next standard up is what? You have to go to 240.6. 150. Yeah.
Then
Conductor wise, you need to size based on 129. Go to the table. It should be one.
oh, and then you gotta, oh, okay. I see.
You size based on the load.
Based on
On the load. No, you size.
I know.
Yeah,
I'm saying
you
what
did.
I
I gotcha. You can. By the way, what you did is the right thing to do. If not, I hate to say the right thing, but the best way to do. But a lot of contractors go down one niche. It saves you some money because the code allow you to do so. Yes, sir.
Yeah, because I want you to let me know if we are doing an over-computation device on this kind of calculation. I want you to tell me when to use a table 430.52.
Table 240.6.
No, table 430.52.
430.52. Only if you have a motor. Have I told you that this amp is a motor? Right? You know, guys, when you size things, you have to work. If it's load, if it doesn't say motor load, then you don't use to. Yeah, you're the one who did 2.5. Yeah, I'm sorry. If it doesn't say a motor, you don't use 2.5. Only for motors. Okay, let's do this in the calculator. Let's do one of them, guys. Here's 123 amps. And Chris, this is continuous load, so I'm going to hit set and wire size. Oops. You better put first 123. 123, hit the amps, and then set and find the wire size. You get you a 2-aught. Now, for you, my friend, for version number 1, what was it? Version number 1. We have 103. If you have 103, 103, see,
Nick, my friend, 103 amps, and then it's continuous load. You hit your set and wire, and you got your number one copper. Cool. Let's move to the last one, gentlemen, because before I give you a quick break here. The last one is piece and cake. Question number 10. Question number 10, it says, why don't you convert this 500 horsepower into a kW? Would you? How do you convert it? You take the 500 multiplied by 746, and what do you get? You get 373 kW. Okay, let's do this calculate on the calculator. This can be done in the. Oh, this is B, by the way. This is Miss B. For Miss A, let's do Miss A. Miss A, the answer for Miss. Oh, this is actually Miss A. This is Miss A. Let's do the Miss B. Miss B is here. Okay, Chad. Move it. Miss B. Here's my B. B, guys, is the answer for B should be 223.8 kW. Okay. Let's do it on the calculator quick. Piece of cake. What's my horsepower? 5 horsepower. 500. And here's my horsepower. I think you hit it right in here. Right? And then hit watts. Is that what you came up with, guys? For the first one? Okay, let's do this one for the 5 horsepower motor. Hold your horses. What did we do different here? Clear everything. Take 500 horsepower. 500, and I believe this is what should be here. Horsepower. Okay, and then hit watts. No, it's calculating.
You need to change
The power factor and everything else.
no, the temperature over there.
Well, but we're not doing temperature though. We're not.
I changed mine. I got this.
Did you?
Yeah.
Well, maybe you cleared your. I don't think it has to do with the temperature though, but I think it has to do with the voltage. The voltage here shouldn't be a function of voltage. What's your power factor? See, my power factor is set at 100. Let me set my power factor. Shouldn't affect that one. Set power factor 100, and if I set my efficiency at 100, and okay, now let's see, 500. Take my horsepower. Please convert it to what? There you go. You know what happened? It was, but I don't know why it was doing a calculation based on the power factor and the efficiency. Yeah. So you have to make sure that power factor, at least the efficiency is 100. If you clear all, yeah. Yeah, I think I didn't clear all, so it defaulted set clear all. Okay. All right, good. That's all I have, my friends. Any question for Chad? Let's have 5 minutes break and then we'll get back.